This now then is the fourth and the last video on pulse width modulation using an 8051 to basically create a certain duty cycle, a certain pulse for the duty cycle. Um, so I have stopped video number 3 by looking at how do I generate. I've shown you in the video 2 and 3 how to calculate general formulas. That was the general formula for your start point if you want to have the high start point. And this is the formula for the low start point. What should that one be? To get me, well, depending on the ADC value, that will give us a certain duty cycle. So what happens with this specific program then is as soon as you get to a certain count, whatever this count was then will be determined by this formula. At this stage, if it was the first time, it will just roll over for the first time after quite a while. And then you will jump into the interrupt service routine, um, which is the interrupt service routine for timer 0. Um, the first thing, as I've mentioned before, status indicates what was the previous status. So I've started this program by saying status should be 0. It indicates that I was sitting at the low level. So immediately it will then switch over to the high level, and then it will load timer high 0 and timer low 0 from my calculation in the main program. So this was stored in the main program, SP high TH0 and SP high TL0 was stored in the main section. And I'm also changing the status here, saying that I'm now actually sitting on the high level. So what's going to happen, of course, if it's the status was 0 in the beginning, it will now change and also go to this new setting. And when I return to my main program, I'm going to start at this specific point. Let's assume it was 25, the percentage duty cycle was 25. Then I am going to start at the correct value, what we calculated before, which was, if I can just quickly look here, 2304. That's the one. It will start then at, well, it's not going to start there. That was the total counts, 2304, but the start point was supposed to be somewhere at F6FF. So that is where it will start. If it was 25% duty cycle, depending on the ADC, you will start then at the correct value. If you should come back and then the status was a 1, uh, then if you've changed the status here, but if it rolls over and you come back, if the status is a 0, no, you're not going to go into this section anymore. It's going to be a 1, then you'll go into this section. And again, you will load the values to timer high 0 and timer low 0, which you derived here, which we did the calculation in the main program. And yeah, then I'll indicate again that I'm sitting at the status of 0, meaning I'm actually pushing out a 0. And this is basically the program. I will, at the end of this video, if you want to get this program, you can contact me via email. I'll give you the email number, just email address just now. If I can just scroll down a little bit, then maybe you can make some screenshots if you really want to. So this is what the program looks like, but I can also send you the program if you really would like that. Let me just scroll down a little bit here. And this is sort of the program. And this program for 100 Hertz signal works perfectly. So as I've said, we have got a specific layout in our course. Let me just close this a little bit. Again, if you would really like to see what's happening with this specific design that we've got here at our place at Tshwane University of Technology, I can also send you this specific file, which is a Proteus file. You can just email me again, and I will do that. Let me just get this a little bit bigger. And what I'm going to do now again is I'm just going to open up. And as I've said here, we can move this specific slider here, and I actually move this down to 0, Um, and you will see then that this, well, it's at 0 here. Although there's a spike there, I could have, if I really wanted to, get rid of the spike also, but you can see that 99.9% of the time at this stage it is low, and as I start increasing the voltage to the ADC, you will see that my pulse width is changing, the duty cycle is changing, and it's going, it's the high section is going to be there, and if you can see there, there's just a blip there sitting as the off time. But again, it's quite easy to get rid of that. I'm not going to go into that detail. But yeah, so this pulse width modulation program with the 8051 is really effective. It really works quite well. You just have to connect some electronics to your motor and then drive the specific motor. In my case, I took the output from P1.0. That's where I took the output from. But again, if you can make use of any output pin from the 8051 microcontroller. Just to show you, um, yeah, this is my detail. It's Motan AJJ at tut.ac.za. I'm a lecturer at Swan University of Technology in the digital department. So you can send me an email if you want to get hold of maybe the Proteus file, which is this one here. Just close this. It's the Proteus file, which I can send to you. I've got this hex file for this. We also used a PIC here. We didn't use a keypad encoder, so we made use of a PIC, uh, which is a cheaper alternative, more cost effective. And then also this program, which we will be placing, or could be the one that you can place into this microcontroller. I can also send you that program then. Good, guys. Thank you, and all the best, and all luck with your studies of pulse width modulation and using the 8051 for that purpose. Thank you.